So last time we were discussing some basics of fuzziness and uncertainty. And we finished our class with the membership functions, where I said that there are many types of membership functions, but they all must satisfy certain criteria that we have discussed last time, that you find also on the slides. The most important criterion is they only should produce values between 0 and 1 in order to be a valid membership function. We also discussed the concept of the crossover point. The crossover point is that point where the membership degrees are 0.5, and usually they correspond to the class boundary that we would define when we do not use fuzzy sets, when we use crisp sets. So that was the membership function. Then I explained to you that the choice of the membership function depends on your model, what you would like to model or which class you would like to represent. And there is always some expert knowledge involved in it. Then we discussed the linear membership functions and the sinusoidal membership functions, and finally, I think the Gaussian membership function. So you have the linear membership function here with the formula to how to compute it. In general, they have 4 parameters, A, B, C, and D, and you can, if you don't want a linear function, you could use a sinusoidal function using some trigonometric function, like in this case, the cosine, which always gives you values between 0 and 1. And as I explained, with these general form of trapezoidal membership function, you can also represent different situations. So you can have trapezoidal, triangular, S-shaped and L-shaped functions that correspond to different model assumptions. And finally, I think I showed you an example of a so-called Gaussian membership function, because it's a bell shape. And you know, in probability theory, we are dealing with bell-shaped functions, and they correspond in a certain way in the shape to such a Gaussian function, where we also have certain parameters, the parameter C and the parameter sigma, that are indicating C is the middle or the mean value and sigma is a kind of spread. So what I would like to show you now is, and this is a new slide that I have added. I still have to add the slide to the website. So there are 2 more slides that will come to the website. And in particular, it's showing you how you can do that in practice. For example, using Excel to compute membership functions. So don't worry. The slide that you see here will appear also on the website. I will just replace the file with the slides on the website with a new version after today's class. Now, as I said, how can we compute membership functions, or which tools can we use? Of course, later we will see that we are generating fuzzy sets in geographic information systems. So we will use functions of a GIS software to generate fuzzy sets. Here I show you some simple examples that we discussed in class last time, how you can use, for example, Excel to represent membership functions. And by the way, we were discussing last time also about the GIS software that you have. I understand that some of you are using ArcMap, others are using ArcGIS Pro, and others have QGIS. Since not everybody has a Esri license for ArcGIS, I decided I am going to use QGIS for the practical examples. As I also said last time, we are not there yet, so it will happen sometime in October that we will be using GIS software. So just keep in mind, I will use QGIS for my examples, and you also have, of course, the option to use QGIS because it's a free software. You can download it and install it. And if time allows, I will also show some the same examples or similar examples using ArcGIS for those who have ArcGIS. But the main software that I'm going to use will be QGIS, which is also a little bit of extra effort for me because I have, in principle, I had all my examples in ArcGIS, but now I'm converting that also to QGIS. But on the other hand, you will see that it doesn't really matter which GIS software you use. You can use fuzzy sets in general and in a relatively easy way in GIS software. But now let's come back to the example. So let's assume we have this example that I used last week in class, the persons, where the height of the person, and we define the class short, average, and tall persons. And of course, for that, we need a membership function for every class. So we need a class for a membership function for short, a membership function for average, and a membership function for tall. Now assume what you see on the upper right side of the screen. You see here a copy from an Excel spreadsheet where you have cells. For example, in cell A2, you have one height in centimeters, and in cell B, C, and D, we will compute the membership values to the classes short, average, and tall. So first of all, we have to define the membership function. The membership function that defines, for example, how do we model or how do we define short. So this is the example of the membership function short. What you see here is that the membership degree is 1 for everyone who is shorter than 150 centimeters. So for all values, for all height values less than 150, the membership is 1. So anybody who is 150 or shorter is definitely short with a membership value of 1. Then between 150 and 180 centimeters, that degree of membership to short decreases. It gets less. So at 150, it's still 1, and at 180, it will be 0, according to the linear membership function. So basically, our parameters here are 150 and 180 that we enter in our linear membership function. And if we go back to our membership function, we are looking at this slope here, decreasing slope. So basically, this is the C is our 150, and the D is our 180. So we go into this part of the equation, meaning D is 180, 180 minus X divided by 180 minus 150, which of course is 30. So when we look at our function here, it's 180 minus X divided by 30 for the range of 150 and 1 to 180. And then if somebody is taller than 180, the degree of membership is 0. Of course, somebody with a height of 180 is definitely not short anymore. So how can we represent that in Excel? In Excel, of course, you can enter formula. You have basically all the mathematics in Excel that is common for calculations. So we will, for example, use this expression in Excel to calculate the membership value for the class short. So again, remember, the cell A2 was our height value, and now we compute the membership degree for short. So we use the if statement in Excel. Basically, what it says here, if cell value A2 is less than or equal 150, then the membership degree or the value is 1. Otherwise, we have to do this part. Otherwise, we say if the value is greater than 150 and less than 180, then the computed value is 180 minus the cell value of A2 divided by 30. And in any other case, it is 0. So what we use here is the if statement in Excel. If you are not familiar with it, I assume that you all have some software that is working like Excel, whether it's the original Microsoft Office or it is a free or open Office version. They all offer these functions that you can use for the calculation of cell values. So we use here the if statement, and then of course there are logical functions like and this and that, and then the computation or calculation of our cell values. Depending on the keyboard language that you use on your computer, this comma here separating the entries in our formula might not be a comma, but might, for example, be a semicolon. So you have to check which separators you have defined in the settings of your operating system. I am using the English language Office version, and in the English language Office version, the separator is a comma. So that's why we have here the comma. As I said, perhaps in other languages, it might be a semicolon. So you have to check in the help of Excel which separator you have to use. So we are going to use this formula for the computation of our class short. Now, the same we can do for average. We define the membership function for average in this way, where we say the membership degree to average is 0 for a height less than or equal 150. Then between 150 and 175, the membership degree increases according to the formula x minus 150 divided by 175 minus 150, which is 25. Then between 175 and 200, it decreases according to the formula 200 minus x divided by, again, 200 minus 175, which is, of course, 25. And then for any height greater than 200, it is 0. So what we generate here is a triangular membership function with an increasing and a decreasing part and a value of 1 at 175. So again, we can represent that in Excel. It gets just a little bit longer. And if you do that in Excel, you always have to be careful that you have the correct number of opening and closing brackets. This is the most tricky thing in Excel when you type in formula, that it is very easy to miss some opening or closing brackets, and then the whole thing gets an error message. So here, again, we use the if statement and we say if the height, the height value is less than equal 150, or greater than 200, we use the or here, meaning we cover this case and that case, less than 150 and greater than 200, then the membership degree is 0. Otherwise, we say if the value is between 150 and 175, then we calculate the value as cell value minus 150 divided by 25, as in this case. And in all other cases, it is this part of our membership function, which is 200 minus cell value divided by 25. And then we want to represent the tall class, and we use this membership function where we say anyone who is shorter than 170 is definitely not tall, meaning the membership value is 0. For a height between 170 and 200 centimeters, the membership value increases according to that formula. This is the increasing part of our linear membership function, x minus 170 divided by 200 minus 170, which of course is 30. And then for every height greater than 200, the degree of membership is 1. So again, we can do that in Excel, giving us this expression using the if statement. If the cell value is less than or equal 170, the value is 0. Otherwise, if the value is between 170 and 200, it will be cell value minus 170 divided by 30, and otherwise the value will be 1. So we can do that now in Excel, and I have prepared a spreadsheet where we can do that. So you should see here my spreadsheet. I have already prepared here a table with the height values. I'm starting at 135, going to 205 centimeters of height. Sometimes I look at my at the chat because I hear there are some messages coming in. So that's what I just did now. Anyway, we have here the height values in steps of 1 centimeters from 135 to 205, and here we will calculate the membership values according to our class definition or the definition of the membership function. So let's start with the short. So what I'm going to do is I'm going to copy that text here. I will add it in here. So what we have here now is our formula for the first cell. Is, as you can already see here, it is the value is 1, because of course with a height of 135 centimeters, according to our formula, the membership value is definitely 1. So what we do now is we just fill it down. So, and what we have here is now our representation of the membership values, or on the right hand side here, a graphic representation of our membership function. And what we can see, we can read here the values. So for example, with a height of 155 centimeters, the membership degree is 0.83. And so on, and it is decreasing, of course. So if someone is 170, let's say 175 centimeters, the membership value is down to 0.166, and this is representing our membership function for short. And of course, we can always represent that in a graphic way. So in the same way, we do it for average. I am copying here formula for average. And I am pulling down the values. Okay, so what I can do is I can format our result. Just show the values with 2 decimal places. And now this green diagram shows us the membership function for average. And of course, what you can see here, you see somebody is pretty short, let's say like 150 centimeters. The membership value is 0. At 175, it's 1. And if you are taller than 175, the membership value decreases. For example, for 180, it's down to 0.8, and it becomes 0 at a height of 2 meters. And in the same way, we can do it for the tall, class of tall people. And also enter our formula here. Okay, made a mistake here. There is one equal sign to money. Okay, so, and then again, we calculate our values. And you can see here now the representation of our membership function for the class tall. You can see here that up to 170, it's 0, then it's increasing, and at the height of 2 meters, it becomes 1, and then there it stays 1 for everyone who is taller than 2 meters. So you can see that with Excel, you can easily represent membership functions.